Okay, so continuing on with functional groups. Remember this string of functional groups here are all things that I mentioned have this one part which we call a carbonyl group. All right, but a carbonyl is just just refers to any type of carbon double bonded to an oxygen. All right, so the next one we're going to talk about is an ester. All right, and if you compare an ester to a carboxylic acid, they kind of look very much alike. All right, you've got this carbonyl group right here. You've got this single bonded to an oxygen here. And the only difference between the carboxylic acid and the ester is that instead of this being a hydrogen here, this is going to be an R group. All right, so it's got to be a carbon right here. All right, esters are fairly important. They tend one important difference between carboxylic acids and esters is carboxylic acids are going to tend to be soluble in basic solutions, whereas esters are not going to tend to be not soluble in basic solutions. Most famous example of an ester is going to be this one right here. If you wanted to use the formal way of naming it, that would be ethyl ethanoate. All right, so just to let you just to go over that. So this part right here, if that were to be a carboxylic acid, that would be ethanoic acid, just like this one right here. All right, so if it's ethanoic acid, if you name it as an ester, you just change the ic to an ate. All right, so that's where the ethanoate part comes from. And this part right here is an ethyl group, so that's where the beginning part of it comes from. All right, the more common name for this is going to be ethyl acetate, for the same reason that this is more commonly called acetic acid. All right, so this right here, instead of having an oxygen right here, you had a nitrogen right here. All right, and notice that with nitrogen we need two other bonds. All right, so either of these could either be R's or H's out here. It would not matter. But anytime you've got this carbonyl carbon, which is single bound to a nitrogen, that's going to be what's called an amide. All right, I believe the IB textbook calls it, or in the questions they call it a carboxamide. All right, but most people are just going to refer to this as an amide. All right, so I don't have any common examples here. But these are extremely important bonds because they're the type of bond that links amino acids together in proteins. All right, so if you've ever heard of a peptide bond that links amino acids together, this is the type of bond functional group that's going to be in that bond. All right, so moving on. Next one I'm going to talk about is a nitrile. All right, so nitrile is anytime you've got a carbon triple bonded to a nitrogen, all right, where this carbon is covalently bound to. This could actually it does have to be an R group. All right, so this is going to be a carbon here. All right, so a common example of this would be if this was just a methyl group right here. This is called acetonitrile. All right, it's a very common type of organic solvent. But one thing I want to point out about this is you might look at the CN right here and say, well, CN, that sounds kind of familiar. And if you look at the polyatomic ions, if you see CN with a minus beside it, that would be, okay, so again, this is CN drawn as a Lewis structure, but if you shorten it, it's just CN with a minus. That's cyanide, all right? And so one thing I want to point out about this is it could be a little confusing, and the difference between a nitrile and a cyanide is that a nitrile is when this right here, the carbon is covalently bound to another carbon. All right, when it's a cyanide, the cyanide is an ion. All right, so the carbon is not covalently bound. All right, so if you had something like sodium cyanide, all right, that's an ionic compound. The cation is Na plus. The anion is Cn minus, and again, this is would be the Lewis structure for that particular polyatomic ion, and you would name that as sodium cyanide. All right, so the difference is going to be whether it's a polyatomic ion or whether it's just a functional group within a covalently bound structure. All right. So moving on, ethers. Okay. So what an ether is anytime you've got two R groups which are separated by an oxygen. All right. So this has got to be single bond oxygen, single bond oxygen. And again, these are the carbons here cannot be carbonyl carbons. All right. So you might say, well, what if it was a carbonyl carbon? All right. Well, if this right here was a carbonyl carbon, all right, it would be an ester. All right. It wouldn't be an ether anymore. Okay. So a quick example of this, I'm going to give the most famous example is this one right here. All right. When people a lot of times just use the word ether. All right. And when they talk about the word ether, they're literally talking about this one particular ether. All right. If you wanted to use the technical name for it, you could call it ethoxyethane. But it's more typically just going to be referred to as either diethyl ether, and the reason for that is these are both ethyl groups, or just plain ether. And I can't help when I talk about ether to think about a cartoon I watched when I was a little kid. It was an episode of Bugs Bunny, and there's an episode where the evil scientist is chasing Bugs Bunny all around this castle, and they end up throwing an axe, and the axe busts open the bottle of ether, and the ether vapors get everywhere. And that's because ether has a very, very low boiling point. All right. And when this happens, the evil scientist and Bugs Bunny chase each other around slowly, and it's kind of a play on the fact that ether was for a long time used as an anesthetic. When someone was going to have surgery, they would soak a handkerchief in the ether and then put that handkerchief over top of the person's mouth, and they would breathe it in, and they would essentially get the person kind of drunk, which, if you think about it, you don't want to be wide awake when they're amputating a limb or something like that. So anyways, okay. So the last functional group I'm going to talk about is benzene, or it's otherwise referred to as phenyl group. And the difference between benzene and phenyl is the difference between noun and adjective. All right. So if we're talking about this, if I showed you this compound right here, this would be benzene. All right. But if I showed you something with one of these coming off of it, you would describe this as a phenyl group coming off of that other thing. All right. So quick example of this. If I showed you this compound right here, we're going to call this is going to be chlorobenzene. All right. So the reason for that is we're considering benzene to be the base molecule. It's the noun. All right. And we're using chloro here as a modifier of that noun. All right. So that's chlorobenzene. All right. But if you look at this right here, I've got the exact same six-membered ring here as I do right here. The only difference is the way I name this, I'm considering this part right here, propane, to be the base compound. And we're saying this is propane that's got a phenyl group hanging off of it. So therefore I use this as an adjective. I call this 2-phenyl propane. All right. So we'll talk a lot more about benzenes because they have an interesting kind of behavior that's coming up soon. But as practice for this, I've given you a couple of molecules, and I want you to try to find as many of these functional groups as you can within those molecules.